So the second part of 4.1 is performing operations with radicals. And so in order to do that, the radicals have to have the same index or the number that sits on the shelf. Okay, and if they have the same number that sits on the shelf or the same index, then you can add or subtract the numbers in front like you normally would with combining like terms. And so the same thing's going to happen here. So when I add and subtract, the very first thing you want to look at is it the same radical? So I have a root 11 and a root 11 with nothing on the shelf for both of them, which means I can just add the numbers that are in front. So 3 plus 18 is 21, and then the radical 11 is like a variable, and it just gets tagged on at the end. If I look at number 2, it's 4 cubed root of 7 minus 9 cubed root of 7. So again, the radical parts look exactly the same, which means I just combine the numbers that are in front. So 4 minus 9 is negative 5. And then cubed root of 7 is like your variable, so it just gets tagged on at the end. You always want to make sure that the number underneath the radical is exactly the same. And the number that sits on the shelf is exactly the same. So when I look at problem number 3, same idea. They're all just roots. So it's a root 7, root 11, root 7. But the ones that look the same are these two because they have the root 7. So we look at the operation sign here. So it's 5 minus 8, which is negative 3, root 7. And then the root 11 just gets tagged on at the end because it's a different number underneath the radical sign. When you look at number 4, the same idea. Right now, they're not the same. But what we're going to do is because they're not the same, we look to see if we can break it down further. So as I look at 20, 20 is the same thing as either 2 times 10 or 4 times 5. It doesn't matter which one. I'm going to do 4 times 5 and then 2 times 2. And 4 broke down, so we don't look at it anymore. And then we look to see what they have in common. So they have a 2 in common, so that's going to go on the outside of the radical. And the 5 is left over, so it stays under the radical. This one we didn't do anything with, and so it just comes straight down. It's 10 root 5. And then plus 2 root 5. And now when we look at it, we've got the root 5, so we add the numbers that are in front. And so 10 plus 2 is going to give us 12 root 5. When we look at number 5, it's going to be that same process. We look to see, is the number under the radical the same? And it's not. We've got a 24 and an 8. And so the best thing to do then is to try to break it down. So 24, we're going to say is 2 times 12. 12 is going to be 4 times 3. 4 is 2 times 2. Is that the only way to do it? No. We could have started off with 4 times 6, 3 times 8, any of those numbers. Remember, if you break it down, then it's gone. So the 12 is gone, the 4 is gone because we broke it down further. Notice again that this 2 is already outside. So there's already 2 out there. And now when we look for pairs, we have a pair of 2s. So it's going to come out. And then the 2 and 3 right here stay underneath because they didn't have a partner to come out. And then we look at the next one exactly the same. So the minus 4 is going to come straight down. So the minus 4 is going to come straight down. And now we're going to break down the 8 just like we did. So we're going to say, well, 8 breaks down to be 2 times 4, 2 times 2. The 4 we broke down, so it's gone. And then again, we're looking for a pair. So we have a pair of 2s. So it's going to come on the outside. And then we have a 2 left over, so it's going to stay on the inside. So as we simplify, 2 times 2 is 4. And then the 2 and 3 underneath, 2 times 3 gives us 6. Negative 4 times 2 is negative 8. And then the root 2 stays root 2. And now when we look at it and we look at the radicals, notice that you've got a 6 under the radical sign and a 2 under the radical sign. And they don't match. They're not the same, which means you're done. So sometimes when we simplify, maybe we can't add or subtract, but we do need to always simplify down as far as we can go. When I look at number 6, same idea. Notice that this has a power of 3 sitting on the shelf. This has a power of 3 sitting on the shelf. This one has a 16 underneath, so the number's the same, but because it doesn't have a 3, we can't combine them. So I'm gonna combine first. So 3 plus 5 is 8. So we have 8 cubed root of 16 minus 2 root 16. And then we're just gonna break it down to find common factors. If we can, we might not be able to, but we're gonna try. So 16 is 4 times 4, which breaks down to be 2 times 2, 2 times 2. Still 16, so this is still going to be 4 times 4, 2 times 2, 2 times 2. And when I go back and cross off the things that I don't, or that I've broken down further, then you'll notice those 4s are gone. Notice with this one as well is that 8 is already on the outside. So when I look for pairs, I have a pair, here I'm looking for 3 of a kind. So I have a pair of 3s, so it's a 3. I have 3 2s, so a 2 is going to come out, and this 2 stays underneath the cubed root sign. So there's a 2 left over. And when I look at the next problem, this negative 2 is going to come straight down. And when I look for pairs, again, this one is I've got a pair of 2s, so it's going to come out, and I have a pair of 2s that's going to come out. And this time I'm looking for pairs because there's not a number on the shelf. There's really a 2. And so now when I simplify, 8 times 2 is 16. We get 16 cubed root of 2. And 2 times 2 times 2 is 8. And that's going to be my answer. When I multiply, it's a little bit different. When I multiply, I'm going to go outside number times outside number, inside number times inside number. So when it's just one term that we're distributing, then we're just going to distribute like we normally would. And the 4 that I'm distributing is an outside number because there's not a radical sign. So I'm going to go outside times outside. So 4 times 3 is 12. So this will be 12 root 2. And then 4 times 2 is 8. And then it will be root 5. And now when I look at it, this is a 2 under the radical. This is a 5 under the radical. They don't match, which means I'm done. If they both would have been root 2s, then I would go further. When I look at 8, same idea. This is an inside number, but we're still going to distribute it because it's just one term. So I go root 5 times root 5, which is root 15, or I'm just going to leave it as 5 times 3. And then for the next one, I'm going to leave it as 5 times 75. Since it's already broken down, we're trying to look for pairs. When I look at 5 and 3, I don't have a pair. So that's going to stay 15, which is fine. I'm just going to leave that for just a minute though. When I look at 5 and 75, 75 actually breaks down. Think of that as 3/4. So this will break down to be 5 and 5. And so now when I'm looking at it, and I'm looking for pairs again, I don't have a pair in the first group. So this is going to stay root 15. When I look at this second group, I do have a pair of 5s, whether I take a pair of 5s with those 2 or whether I take the 5 here, doesn't really matter. I have a pair of 5s either way. It's just going to be easier if they're next to each other. So the 5 is going to come out, and then the 3 and 5 are left over, and 3 times 5 makes 15. And then this one, because there is the same radical underneath, then I combine the numbers in front. Remember, there's really an imaginary 1 sitting here in front. So 1 minus 5 gives me negative 4 root 15. And this would be my answer. So again, when you have that radical, you just want to make sure that you're distributing it to everything on the inside. So root 3 times 72, they're both underneath the radical, so it stays under the radical. So this will be 3 times 72. And then you're going to go, the 3's on the outside, so it stays on the outside, and this is going to end up being 3 times 2. And then again, we're going to break it down if we can. So 3 doesn't break down, but 72 will. Whatever you choose to do there. I'm just going to go with 8 and 9 because that's the first one that comes to mind. So this is 2 and 4, which breaks down to be 2 and 2, and 9 breaks down to be 3 and 3. So anything that broke down where you can cross out. And again, because there's nothing on the shelf here. There's really a 2. And so we're looking for pairs. So I have a pair of 3s and I have a pair of 2s. You could have paired them up however you want. Just if they're next to each other, it makes your life a little bit easier. So a 2 is going to come out and a 3 is going to come out. And this 2 and this 3 stay underneath. So 2 times 3 makes 6. And then when I look at the next group, there's nothing underneath the radical that you can pair up. And so it stays minus 3 root 6. So what happens is this is 6 root 6 minus 3 root 6, which gives us 3 root 6. And then we get to number 10. And number 10, what I would recommend is because it's 2 terms times 2 terms, just do the box like you normally would do. There's nothing different. The only thing that I would say with the box when it's a radical is maybe when you make your box, make it a little bit bigger. And when you write your answer, write it at the top of your box, and so that you'll have enough room to simplify. And I'll show you what I mean by that. So if I was to multiply, I'm going to multiply these 2 together. And because they're both under the radical, this stays 3 times 6. And then the negative 5 is not in the radical, but the 3 is. And so they're just going to go next to each other. And the 2 is outside of the radical, and the root 6 stays underneath. And then 2 times negative 5 is negative 10. And we just multiply like we normally would. The only thing from here that I see or notice is that 3 and 6, I can break 6 down more. So I can break 6 down to be 3 times 2. And then I'm looking for a pair to pull out. So I've got a pair of 3s. So this box ends up being 3 root 2 when I simplify it. And then once you simplify, combine like terms if you can. Now in this case, I look to see if I have anything that's the same. And notice you've got a radical 2, a radical 6, and a radical 3. None of them are the same, and you have a constant. So if none of them are the same, then you just write them down. So your answer would just be 3 root 2 minus 5 root 3 plus 2 root 6 minus 10. And that would be your answer. Sometimes when you multiply, you get something that works out nice and you can combine like terms, but not always. So just be okay with that. If you can't do it, then you can't do it. That's your answer. The next little group is on monitoring progress. Try a few of these on your own. There's a minus plus problem, a minus problem, multiply, and well, actually a couple multiply. So I would definitely try those and then come back. So pause your video, come back and see how you did. So when we look at number 1, notice that you have radical 2 and radical 2, which means you can combine those two. So 3 plus 10 is 13. So this is 13 root 2. The 6 can break down to be 2 and 3, but there's not a pair, so it's just going to stay root 6. So this is your answer. And then for number 4, you can break down the 63 to be 7 times 9. 9 breaks down to be 3 and 3. This goes away. Again, we're looking for a pair, so it's going to stay 4 root 7 minus 6. You have a pair of 3, so it's going to come on the outside with the 6, and the 7 is going to stay underneath the radical. And so then this ends up being 4 root 7 minus 18 root 7, which is going to give us negative 14 root 7. When you look at the next one, notice this is a cubed root of 5x and a cubed root of 5x. And so because they're both cubed roots, we just combine the numbers in front. So 4 minus 11 is negative 7. Maybe. My computer's going to die. Or it's just being weird. Let's see. Okay, so negative 7, and then it's going to be cubed root of 5x. And we don't have 3 of a kind anywhere, so we just leave it like that. Number 4 is a multiply problem, and we know that because you've got parentheses here, so we're going to distribute. And remember, we distribute, we multiply outside times outside, inside times inside. So this is really like there's a 1 there, so we'd go outside times outside. So 1 times 8 is 8. And then 3 times 2 is going to be 3 times 2. I'm just going to leave it like that for a minute. And then 1 times 7 is 7. And inside times inside would be 3 times 32. And then we're going to break that down if we can. So 3 and 2, we can't break down further, but 32 we can. And so 32 is going to be 4 times 8. And this is going to be 4 times 2. So we can do that, or we can go further. If you can find a pair that's bigger, that just makes your life a little bit easier. So we have a pair of 4s that's going to come out. So this is going to be the same as 8 root 6, because nothing comes out of that one, plus 7 times 4. And then there's a 2 and a 3 left over. So that's going to stay 2 times 3, which is 6. So we get 8 root 6 plus 28 root 6, which is going to give us 36 root 6. And that's our final answer for number 4. When I look at 5, because you have a power of 2 here, that means you have 2 of the same thing. So as we multiply, we've got 2 root 5 and minus 4, and 2 root 5 minus 4. And again, remember that we're just going to write that under, like write it at the top of your box and write it semi-small so you can fit them in. Outside times outside would be 4. Inside times inside is the same thing as 5 times 5. Outside times outside is negative 8, and there's only 1 inside. Outside times outside is negative 8, and there's only 1 out or inside. Negative 4 times negative 4 is 16. And the nice thing about this one is you have a pair of 5, so it's going to come on the outside. So it's going to be 4 times 5. So this box is going to be worth 20. And the reason I like that is it makes it so the diagonals are the same, or like terms, I should say. So 20 plus 16 gives us 36. And then negative 8 root 5 plus negative 8 root 5 is negative 16 root 5. And this is my answer. And then when I look at number 6, it's going to be the same idea. Because it's a power of 3 and a power of 3 and a power of 3, I'm just going to do distributive property like normal. And we're going to go outside times outside. They all have a 1 on the outside. So 1 times 1 is 1 cubed root. And it's going to be negative 4 times 2. And then it's going to be minus 1 cubed root of negative 4 times 16. And so as we break those down, we're looking for factors that we have 3 of a kind. So when I look at factors of negative 4, I've got 2 and 2. I want it to be a negative 8. And so in order to make negative 8, I could have all of these be negatives, and then I've got 3 of a kind. Same thing with 16. I can make that be negative 4 times negative 4 so that it will match up. It's not magic. It's just if I'm trying to get negative 4 times 2, which is negative 8. And so if we flip our signs a little bit, it works out for us. So we get 3 of a kind. So we have 3 negative 2s, which is going to give us a negative 2. And then we have 3 negative 4s, which is going to make it so we can pull out a negative 4. And so negative 2 minus negative 4 is really the same thing as adding. And so we get positive 2. And this is my answer. And that's everything with operations with radicals. So make sure you ask for some help if you weren't sure about any of those, or if you're needing some help on the concept in general. All right, thanks.